Alright, so how can we find the missing angle if we are given a ratio? Now, for every ratio, there are two angles that have that answer, and so these problems narrow it down a little bit by telling us the quadrant that we're looking at. So this interval right here is telling us that we are going to find our answer in quadrant 2, because that's between pi over 2 and pi. So we should draw a generic angle that starts at 0 for standard position and ends in quadrant 2. Our goal is to figure out this angle right here. What angle is it that started at 0 and ended in quadrant 2? That's the theta that we're finding. And so what we need to know is, what's this reference angle that's here? If we can just figure out the reference angle, then we'll be able to figure out the original angle. However, we have to figure out this cosine situation. So we have to ask ourselves, which special right triangle has sides that are -1 and +2? Or basically 1 and 2, forget the negative. And so hopefully you remember the 30, 60, 90 triangle. Of course, now it's not that. It's pi over 6, pi over 3, and pi over 2. The hypotenuse is 2 in that. There's pi over 3 and pi over 6. Whoops. Pi over 3 is across from the square root of 3. Pi over 6 is across from the 1. So if we have cosine, we know we are given the adjacent and the hypotenuse. So which corner are we looking from if the adjacent is the 1? Well, must be this pi over 3 corner right here. This would have an adjacent of 1, and the hypotenuse is always 2. So this must be pi over 3. And so if the reference angle is pi over 3, and the angle x-axis we are touching is pi, then we just have to subtract those two values, and that'll tell us our location. Why do we subtract it? Because we're in quadrant 2, we're smaller than pi. So that's the only way we would end up in quadrant 2, is if we subtract the reference angle. If we added the reference angle, we'd end up in quadrant 3, so we'd be in the wrong spot. Alright, we need a common denominator, so instead of pi, we're going to make it 3 over 3. So 2 pi over 3, take away 1 pi over 3, leaves 2 pi over 3 as the missing angle that we wanted. 2 pi over 3 is the location of this angle right here that started at 0 and rotated into the second quadrant. Let's try one more. Okay, so this time we're between 3 pi over 2 and 2 pi. So we're in quadrant 4. So we start at 0 and we draw into quadrant 4. Okay, now we seek to know which is our reference angle. So we need to know what triangle to look at. Well, this is weird. This is just a -1, so we better put a 1 under it, like we do to make a fraction. So is there a triangle where the opposite is -1? Or forget the negative can be either way. Where the opposite is 1 and the adjacent is 1. Well, sure. That would be the pi over 4, 1, 1, square root of 2. That would have an opposite and an adjacent that was 1. So we must have discovered a pi over 4 as our reference angle. And so if pi over 4 is your reference angle, you want to compare pi over 4 and the x-axis you're touching. We started at 0 and we're finishing at 2 pi. So we want to compare to 2 pi here, not 0. Notice we're in quadrant 4, so we're smaller than 2 pi, so we want to subtract again 2 pi, subtract pi over 4. We'll want to make this be over 4, so this is going to multiply by 4 and become 8. So 8 pi over 4, subtract pi over 4, leaves us 7 pi over 4 as angle theta. That's in standard position and ends in quadrant 4. Hope this helps. Let me know if you have questions.